Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Imagine a European online fashion retailer, 15 million shoppers a month, just launched a flash sale across 12 markets. The dashboard lights up wrong. Click-through on recommended items drops from 12% to 2% in minutes. Over 48 hours, they lose more than $3 million in direct revenue. And here's the kicker. It wasn't a security breach, wasn't a code bug. It was a data pipeline that silently zeroed out inventory for 40% of their product catalog, and nobody noticed because the monitoring tool they built thought zero stock was perfectly normal. This is the kind of expensive silence that anomaly-aware personalization eliminates, and that's exactly what you're going to build today. By the end of this video, you'll own 3 concrete skills that are essential for cloud AI development and real-world systems. First, you'll wire Azure Anomaly Detector and Personalizer into a self-correcting loop so bad data never reaches users. Second, you'll understand multivariate detection, which means watching several telemetry streams together so you catch when inventory, orders, and supplier freshness all break at once, not just one spike, and why it exposes failures that static thresholds miss completely. Third, you'll deploy the entire pattern with managed identity and zero secrets, the secure way that stops your credentials from ever leaking into GitHub. These aren't theory, they're muscle, and we're about to build them. Let's walk through a hypothetical scenario because the details teach the whole lesson. This retailer had 15 million monthly shoppers and a recommendation engine that took 2 years to tune. When a supplier data feed update failed, the integration connector retried 3 times, then quietly backfilled every missing inventory count as 0. To make it worse, the team's homegrown anomaly detector used a static z-score threshold. A z-score measures how many standard deviations a value is from the mean, so they set a fixed cutoff based on that over a 24-hour window, and it had seen genuine zero stock events during past clearance sales. So 0 looked normal, no alert fired. The recommendation engine kept pushing dead products to customers. Click-through collapsed, $3 million evaporated in 2 days, and unsubscribe rates spiked 11% over the following month. The root cause wasn't that they lacked monitoring. It was that they monitored the wrong signals, the wrong way. Let's put the 2 biggest impacts side by side. A $3 million revenue loss over 48 hours, and an 11% spike in unsubscribe rates that erodes future engagement. Lost trust. Compare that against the third bar, which represents what happens if an anomaly-aware circuit breaker had been in place. Near zero financial loss, because the loop would have stopped serving dead recommendations within minutes. This isn't a hypothetical. This is the gap between monitoring infrastructure health and monitoring the business telemetry that actually drives your AI decisions. And that's the gap you're about to close. Quick recall. Why did that retailer's homegrown anomaly detection completely miss the inventory zero out? The answer will lock in the core lesson before we build the real fix. This is the live, adaptive architecture that would have saved that retailer. Think of the anomaly detector as the fuel gauge and Personalizer as the driver. Source systems stream business telemetry into event hubs. Azure's high-throughput streaming platform that can buffer millions of events per second, where the multivariate anomaly detector model compares correlated variables like orders, inventory, and supplier freshness. When it spots a group drift, it fires an event to an Azure function, which immediately injects a negative reward into Personalizer, retraining the ranking policy in near real time. Meanwhile, the front end continues calling Rank API with context features, and decision logs flow to blob storage for offline evaluation so you can prove the policy is improving, not just guess. Quick check. What happens when the anomaly detector spots a group drift? Pause. It fires an event to an Azure function, which immediately injects a negative reward into Personalizer, retraining the ranking policy in near real time. Here's your production cheat sheet. Screenshot this. Every component has a specific job, and leaving one out creates a blind spot. Event hubs buffer the fire hose. The multivariate anomaly detector catches correlation failures that single metric monitors miss. The Azure function turns anomalies into reward penalties. Personalizer adapts the ranking. Log analytics gives you post-mortem visibility. And blob storage decouples evaluation from production traffic. Remember, if you skip the buffer, bursts kill your detector. If you skip offline evaluation, you can't prove the model's actually getting better. Time for a quick recall. When the detector fires, what sequence actually stops the bad rankings? Pause. The anomaly alert triggers a process that can send a negative reward to Personalizer, which then adjusts its policy to avoid promoting items that depend on the compromised data. Now we lock it down. The managed identities get the Key Vault Secrets user role, which grants read access to secrets, giving the code exactly what it needs without broad permissions. Then we fetch each service's endpoint and key and immediately store them as secrets. The key point. After these 4 set ASCII vault secret commands run, there are no plaintext credentials in any script file, in any environment variable, anywhere. Your function will retrieve them at runtime using default Azure credential, which silently gets a token from the managed identity. No keys in code, no keys in config. That's the zero secret foundation you'll build on for the rest of this series. First, you need a historical CSV that anomaly detector will use to learn normal patterns. Navigate to your storage account, open the container called time series, and click Upload. Select your multivariate CSV file. It should have a timestamp column and relevant metric columns like orders, inventory, and feed freshness. It's best to align the column names with the variable names you plan to use in the model configuration. Otherwise, you may encounter training issues. Don't worry about small gaps. The fill-in policy you'll set later will linearly interpolate any missing values. Now let's create the multivariate model using REST calls. Notice the code pulls secrets from Key Vault. No key ever appears in the script. First, you post a data feed definition referencing your Azure blob container and a sliding window covering at least a day's worth of history at your chosen granularity. Then you create the model itself, listing the variables orders, inventory, and feed freshness. Check that variable names match the CSV columns exactly. Mismatches can cause training errors. The model will now begin ingesting history. Training a multivariate model isn't instant. You'll poll the status endpoint every 30 seconds until the model indicates it's done. Training duration depends on data volume. Be patient. If it seems stuck, check that your blob naming convention is correct and that CSV files don't have large timestamp gaps beyond what linear fill-NA can handle. Once training finishes, you're ready to start detecting anomalies. Before we wire the circuit breaker, let's lock this in. Our multivariate model watches 3 specific variables. Can you name them and explain why they must be analyzed together? The circuit breaker lives inside an Azure function that fires on a timer every 5 minutes. The skeleton shows the Python v2 programming model with a schedule trigger. It reads the anomaly model ID from an app setting, fetches its key from Key Vault, and then calls the multivariate last detect endpoint. If an anomaly is found, it delegates to a function that injects negative rewards. We'll look at that next. Knowledge check. How do you know a multivariate anomaly model is fully trained and ready? Pause. You poll the model's status endpoint and check for status. Ready in the response. Training can take 30+ minutes, so never assume it's done instantly. Your application calls Personalizer's rank API with a rich context object. Here, we're including the anomaly active flag, a feature that tells Personalizer there's currently an anomaly in the business telemetry. Because our circuit breaker has been posting negative rewards during anomalies, Personalizer quickly learns to associate this flag with bad outcomes and will avoid ranking items that depend on fresh inventory or feed freshness. That's how decisions stay adaptive, even when the underlying data is temporarily untrustworthy. Knowledge check. Which endpoint returns the latest anomaly result from a trained multivariate model, and how often should you call it? Pause. The detect last endpoint, typically something like jock anomaly, detector, VM twine, on a multivariate, models, model-ide, detect last. Poll it at a regular cadence. Many teams use every 5 minutes. For critical real-time needs, layer the univariate fast path on top. We deploy 2 layers of anomaly detection working together. The first is a fast single metric detector. It watches a high signal metric like checkout completion rate and fires an alert in under a second if it drops. That stops the immediate damage. The second layer is multivariate correlation. It analyzes multiple variables like orders, inventory, and supplier freshness together to identify the root cause and adjust Personalizer's policy so the problem doesn't repeat. Quick recall. We just talked about detection speed versus depth. Which layer catches sudden metric drops fastest, and why isn't that layer alone enough to prevent recurring issues? Pause and think. The answer is the fast single metric layer, but you need the multivariate layer to find why it happened. Even with the architecture in place, production still throws curveballs. Here are the 6 failures most teams hit on day 1, each with a one-liner fix. Model training stuck in running. Your CSV naming or variables probably don't match. Rewards arriving too late. Speed up your feedback pipeline to send rewards closer to the event. Exploration flatlines? The anomaly feature is too dominant. Cap its influence with a learning rate regularizer. Secret rotation takes down everything. Use Key Vault versioning and reload at startup. Sending insufficient data points may cause unexpected errors. Double-check the minimum input requirements in the docs, and use the single point method if you only have 1 point. And over time, the model silently ages. Schedule a monthly retraining automation to keep the detector aligned with current business patterns. Screenshot this list. It's your ops cheat sheet. Before you go, here's your on-call cheat sheet covering 3 immediate operational issues. Issue 1. If anomaly detector returns 429. Too many requests, that's generally a rate limit throttle. Check your current tier's documented limits. upgrade to a higher tier, or implement client-side throttling in your function. Issue 2. Personalizer hits. 4 he or 3 forbidden. Confirm your endpoint region matches the key, allow your outbound IP through any firewall, and verify the managed identity holds the cognitive services user role. Issue 3. Reward average silently drifts downward. That's concept drift. Retrain the multivariate model monthly and set the KQL, Custo Query Language, alert and log analytics we just configured. Keep this grid on your second screen during the week. 1 deployment. Here's the subtle killer. Your multivariate anomaly model was trained on a fixed historical window, say last October through January. But 6 months later, the business has a new product line, promotions shifted cadence, and user behavior changed after a UI revamp. The model still reports 95% success, but it's blind to new patterns. That's concept drift. The cure is an automated monthly retraining function. It exports the latest 90 days of data from Event Hub's capture, creates a fresh model, waits for it to reach ready, and swaps the application setting to the new model ID. The old model stays alive for a week as a safety net, then gets deleted. The circuit breaker function stays untouched. It just starts querying the fresh model. That single automation keeps your anomaly detector relevant for years. If you take only one sentence from this entire chapter, let it be this: anomaly detection that never feeds back into the recommendation loop creates a false sense of safety. You think you're monitoring, but you're actually just watching a silent car crash on a dashboard. The real job, on the exam and in production, is to close the loop, detect, penalize, retrain, and promote. Everything we built today does exactly that. To lock it in, remember, the fast single metric layer, like our circuit breaker, catches a checkout drop in under a second, pulling the emergency brake. The multivariate layer, our Azure anomaly detector model, correlates orders, inventory, and feed freshness to find the root cause, then injects negative rewards into Personalizer so the system automatically retrains and recovers. Together, they form a self-healing personalization loop that prevents a $3 million silence. Before you move on, let's lock this in. What are the 2 layers of anomaly detection we deployed, and what is each layer responsible for? Pause. The answer is a fast single metric layer that catches the drop instantly, and a multivariate layer that diagnoses and retrains the system. One last recall before you go. What service did we use to rotate secrets without downtime, keeping the detector alive during credential expiry? Pause. Azure Key Vault with versioning. The detector reloads the latest secret at startup, so a rotation never takes down the service. Now here's your move. All the code you saw, PowerShell provisioning, Python circuit breaker, reward injection, is in the description. Deploy it in your own subscription. Post your anomaly detector model ID in the comments. I'll jump in and give feedback. Subscribe and ring the bell, because Part 5 drops in 2 days and you do not want to miss the Computer Vision Lab. You've just built a system that saves real companies millions. Let's make sure you can prove it on the exam. I'll see you in the next one. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.